Solving quadratics with imaginary numbers. We've already studied imaginary numbers, the quadratic equation, and completing the square. Today we're going to do a few examples where we're going to end up with an imaginary number as an answer. Remember, the square root of a -1 is equal to I. In order to solve for x, we need to do the opposite, which is square rooting both sides. When I square root, the square and the square root cancel each other out. Now, taking the square root of 36 with a negative in there, that can be broken up. The square root of -1 times the square root of 36. The square root of -1 is I, and the square root of 36 is 6. So my answer is going to be x is equal to 6i and x is equal to -6i, because whenever I take the square root of a number, I always get a positive and a negative version. The next problem is already set up for you. This would be like the back half of completing by the square. They have a perfect square on one side equals a number. So I can take the square root of both sides. The square and the square root are going to cancel each other out, at which point we need to split it into two separate equations. We have the positive version and the negative version. We just said above that the square root of -36 is going to be 6i, and the negative version, -6i. For both of these, we need to move the 13 to the right-hand side, so we subtract 13. That gives you x is equal to. Now, the I, that makes it an imaginary number. So we can't combine these terms because they're not alike. We would say -13 plus 6i and -13 minus 6i. This problem looks a little more difficult, so we're probably not going to complete the square. We're going to use the quadratic formula. In fact, the question even told us to use the quadratic formula. First thing you do when using the quadratic formula is to set the equation equal to 0. I have a -5x on the left-hand side. I'm going to move it to the right-hand side. I've set it equal to 0. Now I need to list my ABCs. Now we can plug it into the quadratic formula. Remember, the quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac, all over 2a. Remember to use parentheses whenever you're substituting, and that it is all over that denominator. Then go ahead and simplify. Remember, a negative times a negative gives you a positive, so we have a positive 7 there. Negative squared is also a positive, so we get a positive 49. At this point, we are ready to break it into two equations. We have 7 plus or minus the square root of -31 all over 10. So we're going to break it into two equations, a positive version and a negative version. That would give me x is equal to 7 plus the square root of -31 all over 10, and the negative version. At this point, we can take the square root. 31, there is no square root. We can't even simplify the 31. However, we can take out that negative. Remember, the square root of -1 is equal to I. Now, here's the interesting part. I have 7 plus I square root of 31. The 10 is under the entire thing. But now that I've made it an imaginary number, I split it into two. Yes, they have a common denominator, but I have to split it into two pieces. I have the real piece here, and then I have the imaginary piece next to it. So it's not written over one divisor. You have two different fractions. And then you're going to do the same thing with the negative equation. Here's one last one. P to the 4th power minus 16. Now, this might look difficult because it's a fourth instead of a squared, but hopefully you can see that this is a difference of two squares. So you start by taking the difference of two squares, basically taking the square root. That's going to give you p squared plus 4 and p squared minus 4. Well, I can keep breaking this up. remember, it's still equal to 0. The p squared plus 4 is not changing, but the p squared minus 4 is still a difference of two squares, which gives me p plus 2 and p minus 2. This is still equal to 0. If we were just factoring, I'd be done, but we're not. We're solving. That means I have to set each of these factors equal to 0. P squared plus 4 is equal to 0, p plus 2 equals 0, and p minus 2 equals 0. We're going to get the p's all by themselves. For the last one there, I'm going to add 2 to both sides, giving me p is equal to positive 2. For the middle one, we subtract 2 from both sides, giving me p is equal to negative 2. And for the first one, we're going to subtract 4 from both sides, giving me p squared is equal to negative 4. But I'm not done because there's a square, which means I have to square root both sides. That gives me p is equal to a positive 2i, and p is equal to a negative 2i. So I have 4 answers for this problem, which should make sense since it was p to the 4th power. I have 4 answers. My 4 answers will be p is equal to 2i, negative 2, and 2.